Hi, my name is Brian Jones, and I'll be the instructor for PH 121 General Physics 1. And in this introductory video, I'm going to talk to you about three important points about the course. First off is this. This is a physics course, but there is nobody in the class who is going to be a physics major. As a matter of fact, with the exception of the second semester course, Physics 122, there's nobody in the class who's going to take another physics course. This is a physics class for students who are in other fields. Most of you are in the life sciences. Some of you are in construction. And we're going to work really, really hard to have applications of physics that relate to the topics that you are interested in. And it's really clear if you look at the textbook for this course. Now I've got a paper copy of the book here. The one you're going to use actually will probably be the e-book because we're using the bookstore's inclusive access program. We'll talk about that, and I'll send you information about that. But if you look at the book, and by the way, this is College Physics by Knight, Jones, and Field. I am the Jones in the title, so I have a interest in making this book suit my particular class. I wrote this book so that I would be able to have a good book for my class. And one of the things I wanted to do was to have a physics book that was targeted to people and subjects other than physics. So if you look at chapter 15, Traveling Waves and Sound, first image, a bat. And we talk about bats in the chapter, how they produce the sounds that they do, why they produce the sounds that they do, and how they use them to find insects. And it turns out, just a tidbit here, a bat, when it makes its screech to kind of like locate insects, the sound intensity is greater than the sound intensity you are capable of producing. If you could hear bats, they would be definitely really loud. They're working at a higher frequency and we can't, but if you could, oh my goodness, the energy is ridiculous, and that's because they're listening for the echoes from tiny little insects. This is an example of the type of thing we're going to consider in this book. We'll look at bats. We're going to look at the energetics of locomotion of different animals. We're going to look at the physics and the forces in the locomotion of different animals. We'll also talk about structures. We'll talk about structures literally, i.e. buildings, but we'll also talk about your skeleton as a structure. How is it that I can hit a board with my hand and break the board without breaking my hand? That's one of the topics that we'll look at when we get to chapter 8. So that's one crucial aspect of the course. This is a course about physics, but it's intended for people who aren't physicists. And the reason why whoever is requiring you to take this course wants you to take it is twofold. One reason is because physics is applicable to everything. We are going to treat such a wide range of applications. But the other is the way that physicists look at things is very, very compact. We have certain physical principles that will apply across a very, very broad spectrum of behaviors. I'm going to show you one example of that. This is a little demonstration involving a blower, which makes very, very fast motion of the air. Lots of motion of the air there. I'm going to blow it over the top of this light bulb, and it turns out the light bulb will actually levitate. I can make it stand in the air. Now the reason that happens has to do with the shape of the bulb and the way the air moves when it goes over top of the bulb. It's lightweight and it's round. That's the crucial pieces of the puzzle. Well, the principle that explains why this happens is the same principle that we're going to use to explain the motion of blood in your circulatory system. In particular, we're going to look at the narrowing of blood vessels around your heart and what adverse physiological consequences that can lead to. So the physics of levitating this light bulb is the same as the physics of explaining why it's a problem if you have a narrowing of one of the arteries leading out of your heart. Fascinating. So a few principles broadly applied. And actually the principle that explains this is basically the principle of conservation of energy. So it relates directly to phenomena that span every possible topic in the universe. I mean that literally. So physics has wonderful applications to lots of different disciplines. It's extremely compact. It's a different way of looking at the world. A few simple rules we use to analyze a wide variety of physical systems. And this is a pattern of scientific thought that whoever is requiring you to take this course wants you to be exposed to. That's one thing you need to know about the course. There's a corollary to this, and I hope you can tell from how I'm talking about this, is that I'm very passionate about this subject, and I'm very passionate about teaching you, the students in this class. I love talking about physics, and I love talking about physics to people in other fields because you have things you can teach me. How did I learn this stuff about bats? How did I learn this stuff about horses? How did I learn this stuff about buildings? From people in the class. I'm counting on you to help me make the course richer and more interesting and more applicable for the students who are in the class. So that's our first point. The second point is this. I believe that anybody can master this material. I believe that anybody can do well in this class. And I absolutely believe this. I have had semesters when nobody who was willing to come to class and put in the effort did not pass. And I want this semester to be one of those semesters. You can do it. And if you believe you can do it, there's good research results that suggest that believing you can do it is sufficient to make it so that you can. Because you're here at Colorado State. You're not a freshman. This is a freshman physics class, but no one in the class is a freshman. You're at Colorado State. You've taken hard classes. You're here. You're bright. You're hardworking. You're capable. You can do this course. Absolutely. I believe this to the core of my being. And I will do everything in my power to set up a course so that you can succeed and to set up a course that gives you the resources that you need to be able to succeed. I'm going to do everything I can because I want everybody in this class to succeed. I want everyone in the class to have a wonderful experience as they're doing it. Now here's the third point, and this is perhaps the most important. You can succeed in this class if you are willing to put in the effort. The way the course is set up is very, very active. Lectures will be active. You won't be listening to me talk. You'll be sitting at tables with fellow students solving problems. You will be active. You will be engaged. You will be working on things during class. You need to come to class prepared, and you need to come to class prepared to work. Recitation sections will be active as well. You'll be working in small groups. You'll be solving problems with the assistance of a teaching assistant. Labs will be active. We will be working in small groups, doing experiments, drawing conclusions, learning about the world. We will have office hours where you can held in a classroom where you can come work with fellow students on homework. So you're going to be active in every time that you're with the PH 121 class. You will be active. You will be doing things. You need to come prepared, and you need to come prepared to be engaged. If you're willing to come, having done the reading, having done the preparation, and being willing to take part, that's how you succeed. That's how you succeed. You've got to be willing to put the time in. And over the course of the week, there are several places where you can show you're putting this effort. Every week, there'll be a chapter to read, and we will have a reading quiz. Every week, there'll be exercises to do in class. We will take one assignment per week, and we will assess it. Every week, you'll have a recitation section with a quiz that will be graded. Every week, you'll have a lab with a lab report that will be graded. Every week, you will have a homework assignments that you can hand in, and it will be graded. Every week, we will also have a mastery exercise. When it's all done, when the homework's in, do you understand the core principles? A quick exercise just to help you test mastery and refine your study if you have other things that you need to work a little bit on. So there are all these different pieces that you can do. If you're willing to come to class and put in the effort, if you're willing to prepare, if you're willing to engage, if you're willing to stay focused and keep the magic happening, I will guarantee you that you can pass this class. And I've set up the structure that way, and I will also commit myself personally to doing what it takes to help you succeed. And I'm joined in this quest by a bunch of capable teaching assistants and learning assistants. I'm not alone in teaching this course. You're not alone in taking this course. I'm so excited to start this journey with you folks, and I look forward to seeing where it takes us over the next several months. I'll see you folks in Johnson Hall 222.